Globally, the issue of standby power is growing.
In most countries, 5 to 10% of power in homes is wasted on standby power. Appliances, computers, television, cell phone chargers all waste power while sitting in standby mode all day.
The global market is now demanding cost-effective solutions to standby power.
Fairchild Semiconductor introduces mWSaver technology that offers efficient and small form factor solutions for achieving lower standby power in your designs. Hi, I'm Arvind Ravishankar, Marketing Manager at Fairchild Semiconductor.
And I'm Jason Guo, System Applications Engineer at Fairchild Semiconductor. The demand for AC to DC external power supplies is projected to increase from just over 3 billion units in 2010 to 4.97 billion units in 2014, a 60% increase in just 4 years.
The largest increase is expected in communications driven by mobile phones. Other AC-DC external power supplies that are less than 15 watts include cordless phones, consumer tablet PCs, PDA, digital cameras, and power tools. While standards to regulate standby power are set globally, power designers know that achieving those standards can be costly and complicated.
Many extra components are needed to achieve standby power ratings. Not only does this affect board size, but it also adds to the cost of the bill of materials. Manufacturers may forego the lowest standby power ratings if the cost to manufacture is too high.
Fairchild Semiconductor introduces mWSaver technology and efficient and small form factor solutions for achieving lower standby power in your designs.
mWSaver technology is an optimized combination of process and circuit technologies that is embedded in key power adapter components.
These power innovations include 5 patented technologies: off-time modulation, JFET high voltage startup circuit, feedback impedance switch, high voltage discharge, and PSR control. Other technologies include burst mode operation and low quiescent current techniques. All components with the mWSaver brand designation will feature the industry's lowest standby or no-load power consumption per component.
Let's look at one of the first products that uses mWSaver technology, the Fan 302HL. The Fan 302HL beats the stringent standby power requirements for less than 30 milliwatt.
The Fan 302HL includes features to enhance the performance of flyback converters, such as high voltage startup circuitry, lowest operating voltage and current at no load, as well as constant voltage control method by secondary side regulation and constant current control method by primary side regulation for battery charger applications. First, let's look at how the Fan 302HL helps your designs achieve less than 10 milliwatt power consumption in standby mode.
Here we have a demonstration board with parameters that indicate standby power in adapters. This is a power adapter with Fan 302HL mWSaver technology, and these are several off-the-shelf power adapters. Let's now look at an off-the-shelf power adapter. This one comes in at greater than 60 milliwatt. Now let's plug in the 5 watt power adapter with the Fan 302HL mWSaver technology. The power rating is less than 8 milliwatt. The lowest rating from the off-the-shelf adapters was 60 milliwatt, and the power adapter with mWSaver technology less than 8 milliwatt.
As you can see, Fairchild's highly integrated solution beats all these off-the-shelf adapters in standby power dissipation. Let's look at the biggest areas of power loss on a typical flyback converter in standby mode. MOSFET switching loss, snubber loss, transformer loss, and losses in the PWM control circuits are highly related to switching frequency. The lower the frequency, the lower the power loss in general.
The Fan 302HL with mWSaver technology reduces standby power by using a patented technology that allows the designs to operate at very low burst frequency.
Here we have a 5 watt Fan 302 demo board with a probe connected to the MOSFET gate to measure burst mode frequency. Let's first look at the normal switching frequency at heavy load around 85 kHz. Now let's turn off the load and look at frequency during burst mode around 60 Hz. The burst frequency is controlled by comparing feedback pin voltage with two burst reference thresholds, V feedback H and V feedback L. Reducing MOSFET switching frequency at burst mode, as an example, ultimately manages power loss in standby mode.
To further enhance the performance of flyback converters, the Fan 302 features VS overvoltage protection that prevents damage due to output overvoltage conditions.
This feature reduces external components, thereby reducing the power solution size and cost.
Fairchild Semiconductor's Fan 302HL helps your designs achieve less than 10 mW power consumptions in standby mode and beats the stringent standby power requirements for less than 30 mW.
The Fan 302HL is just one component that utilizes the mWSaver technology, an optimized combination of process and circuit technologies that are embedded in key power adapter components.
Find out more about mWSaver at fairchildsemi.com/mWSaver.
I'm Arvind Ravishankar.
And I'm Jason Guo. Thank you.